Yeah, comes on everyone. Let's start off. So this was the last thing that we did. Great. Let's go ahead. So let's say we have a capacitor. This is 2C. This is C. This thing has a charge plus Q and this thing has charge minus Q. Initially, this is empty. So find the charge distribution and the heat produced when switch is closed. Let's get this. In this case, there's no battery. How do we do this? Listen, let me show you one. So whenever you have a capacitor like this, right, what we do, it doesn't matter, assume charge Q flowing from one capacitor, just like a battery. So that would be the step one. Right. So find the new charge distributions and apply Kirchhoff's law. So this is 2C, this is C. So this is how we'll assume. Let this guy give charge Q. So if this is giving charge Q, then this will be Q minus Q. And it's a two capacitor. It is simple, but the idea is important. What will you do if there are three capacitors? So this charge Q will flow here and it will touch this. So whichever plate the charge is touching, I will take that as positive. Now, how do you know that is positive? I don't know. I'll assume Q and see what happens. Science will take care of it. So Q will touch here. So the Q will again flow here and come back again. Just like a battery. If you send Q, Q has to come back. Is this making sense? Now, let's go in the loop. I'm going like this, left to right. So the things which I didn't color, right, those are the negative plates. So this is a negative plate and the red one is a positive plate. I'm going from negative to positive. So potential should increase. So minus plus Q minus Q by C. Then I'm coming from negative to positive plate. I'm going this way. So minus Q by 2C equal to 0. End of the day, I'm showing the potential difference must be same. So Q minus Q by 2 is 0. So small q is 2Q by 3. So 2Q by 3 charge has gone away. So the final charge distributions are, this guy is Q by 3 and this guy is 2Q by 3. So you can find the final energy here, which is Q by 3 whole square by 2C plus 2Q by 3 whole square by 2 times 2C. What is heat produced? Heat produced is initial energy plus work done by battery. Here there are no batteries minus U final. So initial energy is only one capacitor, Q square by 2C. Work done by battery is 0 and minus whatever is this value is this. How much is this? Q square by 2C common le lo, 1 by 9 plus 4. That will be half. Q square by 18C, 1 plus 2, 3, Q square by 6C. That would be Q square by 3C. Charge only flows from one plate, right? What do you mean by that? Charge Q flows from here. Now, if you want me to show, I'll show you. So that means this will be minus Q. It will induce a minus Q charge, isn't it? Remember, we had a discussion. Charge doesn't actually flow. It induces a minus Q. That means on this plate, it will become minus of Q minus Q. Clear? In order not to show so many charges, I'm just showing only the positive plates. Same thing. We can cancel charge also. Same story. But let me show you the next question. You'll understand better why I did this. Clear with this? So if you have 3, 4 capacitors, one is full, one is empty, just assume Q from one capacitor, redistribute, go in a round trip and get the charge distributions and apply Kirchhoff's law. Let me show you one more. You guys get the hang of this. You guys do this. So we have a capacitor, 3 capacitors with a switch. This is 2C, this is C, this is C. This guy has a charge plus Q, plus 2Q, minus 2Q. This thing has a charge minus Q, plus Q, and this is empty. Now find the charge distribution when switch is closed. The previous one was easy. You can simply say, both have same potential difference and you can finish it off. Here you can't say anything like that. Yes, page here. Clear? Which plate did you take the charge Q is going from? I will take the 2Q thing. So let's see whether you got the same charge distribution. So I will assume Q charge is flowing from here. So this guy will become 2Q minus small q. Now see, this thing already has minus Q. So you got a small q. So Q minus Q. Now I don't know whether that is positive or negative. I will assume it is positive. The signs will take care of it. The Q will continue to flow and this guy will become Q and Q comes back. That's what I'm saying. You don't get into the headache of, sir, this is positive, that is negative. Don't do that. Just keep it simple. When the charge Q goes there, right, whichever it is touching, so you assume it is starting from a positive plate, and whichever plate you touch is a positive plate. The science will take care of it. And I'll tell you why it works. See, for example, now this is Q minus Q. I'm saying this is positive plate. Okay? Now listen carefully. Now, if I go from left to right, if I go from positive to negative plate, what is the potential difference? Minus Q by C. Agreed? Now you come and tell me, no, sir, that is not the positive plate. How do you know that? The other one is the positive plate. Fair enough. So according to you, if this is the negative plate, then this guy, so you're saying Q minus Q is negative plate. That means Q minus Q is the positive plate, right? Now you're going from negative to positive plate. So what is the potential difference? Plus Q minus Q by C. Take out minus sign common, Q minus Q by C. Isn't it the same? Are you getting the point? So it doesn't matter whether you assume that as a negative plate or positive plate, the science will take care of it. So the general confusion that I see now, people get confused that only. Sir, how do you know this is positive plate? How do you know that is negative plate? I don't know. Start with positive, keep it simple, finish it off. Apply Kirchhoff's loop law in this. I'm starting from here. I'm going from negative to positive plate. So it is plus 2Q minus Q by C. Then I'm going from negative to positive plate minus Q by 2C minus Q by C equal to 0. C goes off, you end up with 2Q minus Q by 2 plus Q by 2 minus Q is 0. 5Q by 2 is equal to 5Q by 2. Interestingly, we got Q is equal to capital Q. That means the final charge distribution. This guy became Q minus Q. This guy became 0. This guy became Q. The 2C became empty actually. Is this clear, everyone? Now, even if I have 4 capacitors, I can do the same. But let's do something even better. Heat produced so you can find initial energy, final energy, jobs done. Now, again, don't say these two are in series. For two capacitors to be in series, they should have same charge. Just because they're side by side doesn't mean it is series. If you see they don't have same charge, this is plus Q, this is minus Q. The same facing plates don't have same charge. Any doubts on this? Understood how we got the distribution? Start Q from one plate and start there. Let's see one more. Same question. Let's say if you have capacitor, but this time you kept a battery also. Let's say this thing has a charge minus 3 CV. This thing has charge plus 3 CV. This guy is empty. Find final charges and heat produced. Now, most people will think there are series, they try to find sequence. Don't do that. If both were empty, you could have done that because you have same charge. The moment you have one charge on the capacitor, game's over. They're not in series. You don't have another way. You have to figure out like this. So we have a battery here. So you can assume charge keep flowing from the battery only. So if you have a battery, give preference to battery. Here also you can take if you want charge Q from a capacitor. It won't matter. Kirchhoff's loop law is a thing which will help you out here. This is where Kirchhoff's loop law is quite useful. Try. You got 2 minutes. Hmm. Okay. So this is how we will start. So let charge Q flow from the battery. I'll take capital Q. So this guy will become plus Q. This guy will become plus Q minus 3CV. The main catch is that Q eventually has to come back. No matter where you start, Q has to come back. So that plate will become Q minus 3CV. I assume that is a positive plate. Apply Kirchhoff's loop law in this. Start from the battery. V minus Q by C minus Q minus 3CV by 2C. You came back to the battery. So we have 5V by 2 is equal to 3Q by 2C. So Q is equal to 5CV by 3. So this much charge the battery gives. So the final charge distributions are, this guy is positive 5CV by 3, agreed. And this guy is positive, that is CV by 2. This is minus CV by 2 and this is minus 5CV by... नहीं, CV by 2 नहीं है. How much is that? 5 by 3 minus 3, no? Minus 4 CV by 3. There, that's your final charge distribution. You should take 2C, be careful with that. So you know the initial energy, final energy. What is work done by battery? The work done by the battery is the charge flowing through the battery into voltage QV. Then it is done. Heat produced is initial energy, which you can calculate Q square by 2C. Work done by battery, you know, you can calculate the final energy, substitute, you'll get the answer. Are the steps clear, everyone? So if you have an empty capacitor, charged capacitor, and a battery, still you can do the same thing. Kirchhoff loop law is the way to do. So keep the things as simple as possible. Like, you know, instead of trying to learn different ways of solving, keep it simple. Let the charge Q go. Let you have multiple capacitors, battery, anything. Q flows, distribute, solve. Clear? Now, sometimes in these things, right, they won't give you charge. They will say like this. One capacitor is charged to voltage V1, another capacitor is charged to voltage V2, then they both are connected. Getting it? Questions will be framed that way. So I'll just give a general formula. Idea is the same. So let's say we have capacitor here, C1, charged by voltage V1. We have another capacitor here, C2. So indirectly give you the charges C1, V1 and C2, V2. V2. So case 1, connected in same polarity. So you connected the positive plate, C1, V1, and you connected the positive plate, C2, V2. Then the question would be, what is the final voltage? So after closing the switch, the final voltage across them, or you can say common voltage across them, would be C1, V1 plus C2, V2 by C1 plus C2. Easy to remember. You can solve this if you want, meaning you'll take charge C1, C1, C2, V2, assume Q is flowing, you do the same story again. But at least in an exam like mains or bits, right, this is the kind of question they'll frame, so it'll save you time. Remember this guy, Aditya Shrikant, who came, उसका जेई का क्या हुआ, उसका बिट्स प्लानिंग कंप्यूटर साइंस मिल गया. Who he is going mostly. So now you connect it in reverse polarity. So this is your positive plate. This is the positive plate. Again, same thing. The common voltage would be, I'm assuming C1 V1 is bigger, so C1 V1 by C2 V2 by C1 plus C2. Clear? So if they give you voltages instead of charges, this would be a faster way. But the idea was the same. Instead of taking Q1, Q2, you're taking C1 V1, C2 V2. You'll assume small charge Q is flowing. In case you forgot, you do the same thing. Assume Q is flowing from here. This will become C1 V1 plus Q. This will be C2 V2 minus Q. Apply Kirchhoff's law. Done. You'll get the same answer. Then you'll get the final charges. Charge by C1 will give the potential difference. You can remember this. Let's see one more. Next one. We have a capacitor. So we have 2 points here. This is A and this is B, and we have a switch. The switch can be toggled between A and B. This is C, this is C, this is B, and this is 2V. So initially switch is connected to A and capacitor is charged. First thing. So when the switch is flipped to B, so initially connected to A, then you took the switch and kept it B, find the heat produced. Then again it is flipped back to A. Then find the heat. Now if you do this infinite times, you kept on flipping between A and B, find the final charges on the capacitor. Let's get this. This will be a paragraph question. Remember, they're not in series. The left capacitor will be charged, the right one is empty. So don't take them in series. A part is our CV square. Hope you guys are taking work done by battery also. Let's see the first part. So always draw the circuit first of all when that switch is connected to the switch is connected to A. So this guy is useless. It is just hanging in air. You can clearly see single capacitor. So this charge will be CV. This charge will be minus CV. Then you flip the switch. Now this battery 2V is just hanging in air. It is useless. Now some charges will distribute. So assume charge Q goes from the battery. This guy will be Q minus CV. This guy will be Q, and the Q comes back. That's what I said. When you don't know the charges, just assume it is Q and start from there. Apply Kirchhoff's loop law. I'll just remove the battery in the middle. Then you get V minus Q minus CV by C minus Q by C is equal to 0. You get CV minus Q plus CV minus Q is 0. I get Q is equal to C. Wait.
So it will be follow with charge.
कुछ तो गड़बड़ किया ना मैंने.
I don't know.
The charges will be how much? Q is there. Initially, what is the charge on the capacitor? CV only, right?
Yes, sir.
Initially, it is connected to A, so that is CV and all. ठीक है, मतलब what you're saying?
Like possible है ना, like it will be possible.
ठीक है, zero हो गया, वो problem नहीं है. I think just thinking, ठीक है, Q is equal to CV. No, I'm just checking calculations are right now.
Yes, sir.
Then, I didn't want it to be zero actually, but ठीक है. So this guy became 0 and this guy became CV and minus CV. Interesting. And what is the work done by the battery? So you want heat produced. So work done by the battery is simply the charge that flows, that is Q into V, CV square. Therefore, heat produced will be initial energy okay. Heat will be U initial plus work done by battery. And this to be minus U final. U initial, U final both are same. So work done by battery is only CV square. That's your heat produced. Clear? To initial is connected to it. Okay. This is the first part. Now you're flipping the switch back to A. Now what? The switch got connected to B here. A is just hanging in the air. Now if you flip the switch back, now what is the heat produced? I'll do one thing, wait. Let's change the question. This thing became too easy actually. I'm not happy with this. Initially switch is connected to B. Then you flip the switch to A. Then you flip the switch back to B. This is better. Let's try this. Initially switch is connected to B. Then you flip it to A and then you flip it back to B. I change the question. Let's do this again. I don't like easy things. Yeah, that was not wrong. It was fine, but we lost the track. This is better. Let's get this. Yeah, initially charge will be same. Initially you can take series because both are empty. Let me show the first part. So initially the 2V battery doesn't work. So C equivalent is C by 2. So this guy would be CV by 2 minus CV by 2, CV by 2 minus CV by 2. Now flip to A. This capacitor on the right will be just hanging in air. So that is gone. So assume charge Q is flowing from here. So this guy will become Q minus CV by 2. Q again goes back here and Q comes back. Now apply Kirchhoff's loop law in this. This would be 2V minus Q minus CV by 2 by C minus V equal to 0. That would be CV minus Q plus CV by 2 equal to 0. Q is equal to 3CV by 2. Yeah, that you could have seen and told, but fine. That is important, why you need to understand. So the final charge on this capacitor is mm, 3CV will go there. So how much is that? This will become CV. This will become minus CV. Okay. Now here, what is work done by batteries? Now remember, there are two batteries here. That would be Q into 2V, the charge is coming out of the battery, minus Q into V, the charge is going into the battery. Hope you didn't just add them both. So if a charge comes out of the battery, this is discharging. So it is actually giving out energy. The work done by the battery will be plus QV. If the same thing, if the charge enters the battery, you're going from high to low potential, you're charging the battery. I mean, the battery is absorbing the energy. So be careful with the convention. So even that has a convention. One battery is absorbing energy back. So this guy would be QV. That is your work done by battery. Q is 3CV by 2. So 3CV square by 2. Now heat produced will be U initial, which you can calculate. CV by 2 whole square by this thing, half CV by 2 plus work done by batteries. You have to take both of them minus U final. There. Anyway, the right side capacitor is unaffected, so that will just remain same. You need to bother only about the left capacitor. To find the energy in this left capacitor, find the final energy of the left capacitor and the work done by batteries. How much are you getting? 5 CV square by 8? Ishan, did you subtract the battery work done or?
Yes, sir. I subtracted it.
Okay, so Ishan says he got 5 CV square by 8. So do check your answers. Clear? So you can solve this thing. That's why I said this was better.
So after the switch is flipped to A, we can take equivalent EMF now of the batteries.
After the switch is flipped to, you can do that.
I did that
You can
actually.
do. वही
Yeah.
किया मैं भी देखो ना वही तो हो गया कुछ oslo में.
Yes, sir.
I just wanted to show nothing else. Meaning, I showed you one pattern, then just doing the same thing. Now what? Now the switch is flipped back to B again. Now what? Any doubts on this switch? Please ask me. So there is one new thing here is if the charge goes into the battery, you have to take minus. So be careful with that. One battery is giving energy and one battery is absorbing energy. The work done by battery need not be positive every time. Let's see. Just read out the circuit. So This was plus CV, this was minus CV, this was CV by 2 and minus CV by 2. Just give me a minute, right? Someone is ringing the bell. Let's see, Amazon parcel. I ordered some chocolate. Let's see. It is some OT homemade chocolate, it seems. I really don't know what it means. I said try karte hain, but now what you're doing, you're flipping the switch back to B. Now be careful when you flip it back to B. Now they won't be series. In the beginning, you took them as series. Now they won't be because the charges won't be same. So let charge Q flow from here. This guy would be Q minus CV. This guy will be Q plus CV by 2, and Q comes back. Get the charge distribution? Just keep giving Q. Whatever is already there, add plus Q to that. And then go in this way, write the equation V minus Q minus CV by C minus Q plus CV by 2 by C equal to 0. So CV minus Q plus CV minus Q minus CV by 2 is equal to 0. That's 2Q plus 3CV by 2 is equal to 0. Q is equal to 3CV by 4. There. So your final charges would be this guy becomes plus CV by 4, and this guy becomes plus 5CV by 4. Those two are the postulates in the middle. Then again, same story. Heat produced will be U initial plus work done by battery minus U final. Here work done by battery would be small q into V, which is 3CV square by 4. You can substitute. Now you see, just starting with B and going to A, how messed up the question became. I mean, this is better. There are more variations in this. And you will notice something here. When you keep on flipping the switches here, right, they're tending to something. This capacitor on this plate, right, is getting charged slowly, slowly, slowly. So now if you do this infinite times, what will be the final charges? How do you approach that? After doing this 2-3 times, you'll actually get a sequence. You will see the charges are changing in a particular sequence, but there's a much faster way to do this.
Well, can the energy come negative?
Energy or heat
Heat.
can't come negative. Maybe initial तो दोनों को लेना पड़ेगा God. I hope you took both of them. Because
Yes.
energy in both the capacitors is changing.
Work done is 3 CV square.
Plus by 4 ना वो. So initial plus work done minus this. Check करो. I'm not sure.
Minus
It's
2
not
by
like
16 R.
interesting answer. नहीं, that would be wrong actually. Check करो. Maybe calculations are messed up. I don't think so. You should get it. Until unless I messed up some calculations here. Looks right actually because ये पूरा charge 3 CV by 2 होना चाहिए. So this charge is 3 CV by 2. Will they both charge to CV? Now see this thing. Now if you kept on flipping the switch between A and B, eventually you'll reach a point where whether you keep the switch at A or keep the switch at B, the potential will be same. If you keep on flipping the switches, the charges will distribute. You'll reach a stage where, right, whether you keep the switch at A or B, the answer shouldn't change anymore. The charges should have same capacitors. The capacitor should have same charge. Is that making sense? You can observe this thing. See, initially how much charge was there? CV by 2. Now how much charge was there? 5 CV by 4. So it is getting slowly filled up. At one point, the right capacitor will be having so much charge, it won't let any more new charge come into it. So we can make an educated guess from this. So after infinite times, after infinite switch flips between A and B, charges become constant. You know what we're doing exactly? It is kind of like this. We have a water tank. Okay. Think of like this. Let's say this the water tank is full. Both are connected. What will happen? This will become half. This will become half. Okay. Then open the switch. Now fill up the tank again. Now again connect them. Now what will happen? This will become 3/4. This will also become 3/4, right? Now again open the switch, fill up the tank. Now again connect them. You're getting what is happening? You're incrementally filling up the right one. Eventually you'll reach a stage where this thing and this thing are completely full. Water won't flow only even if you connect a switch. You're getting the analogy? So every time you switch the flip back to, see, every time you put the switch back to this point, what will happen? This will always become CV, right? When you come back to A, the charge always, this will always become CV. Only when you flip it back, this charge will keep changing. Is that making sense? So eventually you'll reach a state where that is potential at A becomes equal to potential at B. Means it doesn't matter for the circuit whether you're connected A or B, right? So there is no charges become constant. So there is no redistribution of charges. Why there is no redistribution? Because the potential becomes same. If A and B have same potential, the capacitor doesn't mind wherever you are.
So
All right.
in this case, if we are saying it is filling by half and half, after the
Mm-hmm.
second condition, how did we get 5 CV by 4?
Or I just give some random example record.
But still, we should not be able to get more than the capacity, no?
But this thing has a 2V battery sitting here record
No.
that can go up to 2 CV.
Sir, but whenever we connect for the B wala charge, for the 2V battery gets disconnected now.
Well,
It only charges the A.
so let me
And
complete
the
it.
residual
देखते
position
हैं.
of V.
That thing I just gave a random example. Right? I was just trying to give an analogy like what is happening. It doesn't mean it will be equal. You can say VA is equal to VB. That is A and B can be connected. So after infinite time, the circuit, right, would look like this. This point, right, A and B both become common points. Are you getting what I'm trying to say now? Every time you flip the switch
Yes,
back to
sir.
A, the left capacitor keep on getting filled. So this is what you're doing, isn't it? You're filling up the left capacitor. See, you're filling up the left capacitor, and then you flip the switch. The left capacitor gives some charge to the right capacitor. Then again you're flipping the switch. Again the left capacitor becomes CV. Again you're giving charge to the right capacitor. Continuously you're playing the same game. At one point, the right capacitor will have so much charge. Now I don't know how much is that. It could be equal. It could be more or less. I don't know how much ever it is. At one point, this CV charge, even when you connect it here, the charge won't flow only to the right capacitor. You getting my point? Because you can see incrementally as you keep on filling, right? The right capacitor, there is a limit. At one point, it will resist the charge flow. Meaning it has become A and B, the potentials have become same. It doesn't matter whether you keep the switch at A or B, or if you connect to both of them. Now it is making sense? Because whenever you come back to the left capacitor is always getting CV. Ishan?
Yes, I got it.
Now it makes sense. So bus ho gaya na? Now you can start solving this thing. So we can say assume charge Q flows here. This is Q. This is Q minus Q. Apply Kirchhoff's law, Actually, you can easily see and tell here, but ठीक है, लिख लेते हैं. So this will be 2V minus Q by C is equal to 0. So basically the right capacitor becomes 2CV. The left capacitor will be 2V minus Q by C minus V equal to 0. So actually we'll get Q minus Q is equal to CV. So these are the final charge distributions. You did not apply Kirchhoff's law actually, you could have seen directly, but yeah. So finally, this guy will remain CV like expected, and this guy will remain 2CV, and done. Now, no matter how many times you flip, the charges won't flow. Is this making sense? Because see, once the left capacitor is CV, whether you flip the switch or don't flip the switch, the charge will remain CV only. So instead of doing it n number of times and then putting n tends to infinity, you can come up with this logic saying every time the charge goes to the second right side capacitor, at one point the right capacitor will be full. It won't let any more charge come inside. Is this clear, everyone? Nice, Ishan. Have something.
Yes, sir.
Let's see one more. It's a pretty good question. It's an advanced paragraph question. The heat produced and all, it's a pretty good one. It's not tough. You just have to be careful. Draw the circuit, see what is happening, see how much charge is flowing. Step by step, you have to do it aram se. Let's see a little different one. We have a shell, we have a shell, we have a shell. 3 shells. This I wanted to do last time only, but okay. There is a small hole here. This is radius r. This is 2r. This is 3r. Concentric conducting shells. You connected the battery between the inside and outside and voltage is V. And here we have a switch and the center one is ready to be grounded. So find the charge distribution before and after closing the switch. Mhm. Let's get this. Let's see, will you figure it out, the trap. Let's see. What is the formula for capacitance? That is a problem we have in life. All the complex things we do, and we don't know the capacitance of a spherical shell का formula. 4 pi epsilon R1 R2 by R2 minus R1. इतना अच्छा आंसर आ गया है. Listen. First of all, how many capacitors are there here? How many capacitors are there? There are 3 capacitors. There is C1, there is C2, there is a C3. C3 is from outer shell to infinity. There are 3 capacitors here. You're getting it? So C1, again, remember one thing. When you say capacitor, exactly what is a capacitor? Capacitor is not the plates. Capacitor is the space between R to 2R is a capacitance. Space between 2R to 3R is a capacitance. That space is the capacitor, not the plates. Plates are just the boundary of the capacitor. So this is the capacitance between R and 2R. C2 is a capacitance between 2R and 3R. C3 is a capacitance between 3R and infinity. Now, if you try to draw the circuit, nodal analysis, let this point be A, let this point be B, and this guy will be C. It is before grounding. So point A, point C, and point B. The battery is between A and B. So the first capacitor C1 is between A and C. The second capacitor C2 is between C and B. The third capacitor C3 is between B and infinity. But the battery is connected between A and B. So this is kind of useless. There is a capacitor, but it doesn't work. Both of them are in series. So find C equivalent and finish it off. C1 would be 4 pi epsilon R into 2R by 2R minus R. C2 would be 4 pi epsilon 2R into 3R by 3R minus 2R. So you won't get, I don't think you'll get good answers. Capacitances are not that straightforward. The last one will be 4 pi epsilon 3R. These are the 3 capacitances. This is how the circuit looks. So C equivalent will be C1 C2 by C1 plus C2. You'll get the charge distribution done. The interesting part is when you ground it. Now what will happen when you ground this? Try. If you ground the middle plate, suddenly something changes. So that would be the question. Find the ratio of capacitance before and after grounding. Yeah, when you ground, the potential at V becomes 0. And the potential at infinity also is 0. Now suddenly C3 will come in the picture. So in the second part, the moment you ground this, the potential at C becomes 0. The central plate is 0 potential. And don't forget, your plate at infinity is also 0 potential. So now if you try to draw the circuit, so we have A, we have 0 potential here, which is ground. And we have B. So your capacitors, first one is between A and the ground, C1. C2 is also between the ground and B. C3 is also between B and the ground. So suddenly C2, C3 become parallel. And here you're connecting the battery. Make sense? Now the capacitance changes. So grounding that middle plate suddenly will make the whole potential difference. So infinity is like a common terminal. It will become a common terminal. Because infinity is a zero potential, the center one is a zero potential. Clear, everyone? So they can ask a pretty good question. Find the heat produced when the switch is closed. So C current will change. So work done by battery will be there. Initial energy is different. Final energy is different. This would be a good advanced question. A more than one choice one. I hope everyone is clear. What happened with that C3? Initially, C3 was just hanging in air, so you can remove it. But now it gets connected back. Which part? So I was just saying, if you ground the middle plate and the infinity, both are zero, right? The middle plate and the infinity will be a common terminal now. So basically, previous question में ये जो है ना, this you're bringing and connecting back to the center. So now C3 will come in the picture, na? Okay. All got this? It's a good one, simple one, but tricky. Like you need to figure out that infinity is also a capacitor. And when you say capacitor, understand capacitor is not the plates; it is the space between the plates. Like if you remember, that's how we started the whole story. Capacitor is something which stores energy in the form of field lines. The next one, dielectric slabs. Now, if you remember in the beginning, when we tried to find the capacitance, we figured out by changing area, it's not economically viable. And if you decrease the distance, there is a chance of dielectric breakdown. So the third way to increase the capacitance is by introducing material between them. So if you have a capacitor, parallel plates A, distance is D, this is vacuum. So capacitance is given by A epsilon by D. Now, if you fill up this medium with a dielectric, you can actually touch this thing also. There's no problem. I'm just leaving a small space. So this is a dielectric slab. Dielectric slabs are generally insulators. So there's no problem of shorting. So even if you touch the metal plate, there is no problem. Now here, this K is nothing but, it's called dielectric constant. Basically, this is same as relative permittivity. I'm not sure why they used K here, but every book you'll find that. So be careful. This thing we did epsilon R, if you remember, which is epsilon medium by epsilon naught in Coulomb's law. This is same as K. Both are one and the same things. So we write epsilon R as K here. Now what happens here? Now the capacitance in the medium would be A epsilon medium by D. This becomes K times A epsilon naught by D. This is K times C vacuum. So capacitance increases. Now example, if you take for zinc sulfide, generally this zinc sulfide, K value is almost 4,000. So you can increase the capacitance by 4,000 by coating inside with zinc sulfide. It has multiple advantages. The first advantage, if you just keep the plates in vacuum, there's a high chance the plates might become like this. You can't maintain the space. So what they do, they take one plate and they coat with the zinc sulfide, and you can coat it with as thin layer as possible. So the thin coating of zinc sulfide. And now you can keep a plate on top of it. It's like a sandwich. You keep a thin layer of jam and you're putting two bread pieces. This is a coating of zinc sulfide. So this thing, right, provides mechanical strength. It provides constant distance and mechanical strength. It makes sure the capacitor doesn't break or anything. Because if you leave empty space, there's a chance it'll get distorted. Mostly a CET equation. And then you put a plate on top of it. So it is pretty easy to manufacture that way. And if you put a conductor, now this thing you should know for conductors, try to understand what is epsilon r. It's a resistance to field. For conductors, K tends to infinity. That means the capacitance becomes infinity. I mean, you can't store anything. So it gets shorted basically. The distance between the capacitors becomes zero. Have a look at this bit. So this would be a new formula whenever you introduce a medium.
So if capacitance becomes infinity, isn't it a good thing? We can store
Where
infinite charge. Q equal to CV, no?
infinity meaning C. Problem wo hai. Q is equal to what? CV, right? C becomes infinity, but V becomes zero. There is no potential difference.
So we can connect it by a battery. There will be potential difference, no?
You'll get sparks. See what you're talking. So you're saying you'll connect a battery like this.
Oh, so okay, never
You'll
mind.
blast the battery there. You're getting that C is actually right. Infinity meaning is actually undefined. There's no charge. There's no potential difference. It's actually 0 by 0. Clear with this? Now, what exactly happens inside? So consider the two parallel plates. With a dielectric slab between them. So the moment you connect this thing, right? So this thing will have plus Q. So there is a plus charge on this plate. There's a minus Q charge on this plate. Now understand the difference between a conductor and a dielectric. In a dielectric, the electrons are not free to move. So they do get attracted, but they can't come out of the nucleus. So you start getting dipoles. In case of a conductor, the electrons are so loosely inside the nucleus atom, they'll just come outside and start roaming. They'll go to the edges. In a dielectric slab, it's mostly like an insulator. They can't come out. So you start getting dipoles. So in a dielectric, the concentration of free electrons is very less. So unlike a conductor, which cancels the external field, you can't do this here. They will try to reduce, but they can't cancel. So here, electrons which cannot. What are free electrons? Electrons which can freely move across the nucleus. That we wrote before, but let's write it again. Electrons which can freely move in the lattice are called free electrons. So these dipoles do create an electric field. This thing I showed you in dielectric breakdown. So you have a force here, EQ, you have a force here, EE. So this thing will get distorted a bit. So basically the plates would create an external field and this dipole between this will start getting dipoles. Clear? What's happening? Take a break. Come back by 7. We'll continue from here. Any doubts so far? Anything not clear? Okay, take a break. Come back in 10 minutes. Next thing.
sir.
Hmm.
So what were you saying about the free electrons being less here? Like उसका क्या relation है इससे?
Insulator है God.
नहीं सर वो समझा but like you were saying कि मतलब free electrons होंगे तो क्या होगा? Like you said
If
something.
it becomes a conductor, na, then what would happen? You have a lot of electrons for them to move. You will distribute, accumulate so much charge, they can finally fight back and oppose the field.
ओ अच्छा यहाँ पे उतने इलेक्ट्रॉन है तो they cannot oppose it.
Yeah.
So that's why वो
The
break down नहीं हो
field,
रहा है.
there's nothing. They'll just expand and they just stay there.
Oh, okay sir.
देखते हैं, you will see. The field inside won't be zero now. Remember, in a conductor field is zero.
Oh yes sir.
In a dielectric field won't be zero.
Yes sir.
Because if you remember the statement, we used to write like, there are so many, think of like this. It's like, remember that room example I keep giving. Now, what if the room there is only 5 people and 5 people? Even if I throw all the 5 here, everyone is okay with us.
Yes sir.
Something like that. Meaning you don't have enough charges, to oppose the battery or whatever.
And
Chalo, everyone,
sir-
comes on.
And sir, like inside the dielectric, the electric field will be uniform, right? Inside
It will
the.
be uniform.
So, agar like if we had a circular dielectric ka thing,
Then it won't be uniform. Here it is a slab, na? We are taking it to be a thin slab. So we can take it to be uniform. We discussed this before, right? You asked me this once.
हाँ sir.
Then the thickness won't be same, na?
नहीं sir. Sorry sir, क्या?
Thickness won't be same, right?
Uh,
Chalo, scams on everyone. We'll discuss end of the class if you still have a
okay.
doubt.
Yes sir.
But you asked me this thing before also.
I know sir. Actually, वो मैं reason भूल गया मैं. So like.
Chalega. So if you put a dielectric slab here, so sigma is your charge per unit area. Now what will happen? This will induce the negative charge here. Again, the same thing due to the dipole here. So this charge will be minus sigma I, this will be plus sigma I. So inside now there are two fields which are fighting. One is due to the plate. The second one is the E induced. So the field due to the plates would be sigma by epsilon. There are two of them. Whereas a field due to the induced charges would be sigma induced by epsilon. And we saw from Coulomb's law, whenever you keep this thing in a medium, the field or the force becomes 1 by k times. Same thing we discussed in Coulomb's law also there. Field inside the medium becomes 1 by epsilon r times. So that will be 1 by k times here. Meaning this is what would have happened. If the field outside is E, the moment you enter the slab, the field will reduce to E by K because of the induced charges. And outside again, the field will be E. So the field inside is whatever is outside by K. So E inside is simply the field due to the plate. Again, vectors. E due to the induced charge. This guy is whatever is outside, that is sigma by K epsilon. This would be sigma by epsilon minus sigma induced by epsilon. From here we can see sigma induced will be sigma into 1 minus 1 by k. If you remember the same formula we derived in, not the same thing, we derived the field due to the induced charges. Force is 1 minus 1 by k. This is the induced charges on the plates. Now for conductors, K is infinity. Then sigma induced becomes equal to sigma. Isn't that what happened in Gauss law? When you put a conducting plate, you always get equal and opposite charges. So in case of a dielectric slab, you don't get equal and opposite charges, you get slightly less. So this is what I was saying, Kush. You don't have enough electrons to create enough charge to oppose the field. In case of a conductor, you have enough free electrons or enough electrons for the charge to distribute continuously. But in a dielectric slab, you stop. That's an important result. What are the induced charges on the dielectric slab? Yeah. So here we can so just let me write down that again. So if this was sigma, if you put a conducting plate, you will get minus sigma induced plus sigma induced. So sigma induced will be sigma into 1 minus 1 by k. Now that means you can actually use this for this also. Suppose if I have two conducting plates, so you can be sure this will be Q and this will be minus Q, right? But what if this is a dielectric slab and this is a conducting plate? Now the charges would be, you can put a conductor, but there's a chance the conductor will touch the plates and will get shorted. So now if this would be Q, this charge here would be minus Q 1 minus 1 by K. Make sense? So the opposite plates won't get the equivalent opposite charge, but you'll get something less if you put a dielectric plate. So they can frame questions like this also on Gauss law. So just to give an example, you tell me what is the answer for this. It is straightforward after that. Let me show it in the next page. But clear with this? And we also define something called polarization. Polarization is nothing but dipole moment per unit volume. So here dipole moment is simply the charge Q induced into distance by volume is A into D. This becomes simply sigma I. So dipole moment per unit volume is the induced charge only. Yeah. Let me show you a question on this. Any doubts on this? They'll frame a question like this. We have two conducting plates. This charge is plus Q minus Q. Then you took A. This is a neutral. I'll just shade with some color. Dielectric plate where K is equal to 3. A is given charge Q, that thing is 0 charge. Find the ratio of force between A and B and between A and C. So I want the ratio between force between AB by force between AC. So we have two parallel plates. You can take them as large plates. Distance is very small between them. You can treat them as infinite plates. So in the case one, A and B, they have charges plus Q minus Q. Second case, it is plus Q and 0. Find the ratio of force between plate A and B and plate A and C. Just to give a little idea, the force will be only due to the charges between the inner surfaces. The outside surface charges don't interact with inside. Remember, the field doesn't come inside only. Three by two. Anyone else got this? Four. First, let's see the charge distribution. So between A and B, I hope you remember the charges will distribute as Q1 plus Q2 by 2, Q1 minus Q2 by 2. So in this case, this is plus Q, and this is minus Q. Outside will be 0, 0. So there's no problem anyway. The force between A to B will be simply minus Q square by 2A epsilon. How did we get this? You can say charge on one plate into field due to the other plate. This is how we proved between force between two plates in a capacitor. Charge on a plate into field due to the other plate. You can't take your own field. So that would be minus Q, and the other guy would be sigma by 2 epsilon minus Q square by 2 epsilon. Minus indicates attraction. I could have made it better. I could have taken Q1, Q2. Then Q का place में क्या आएगा? Q1 minus Q2 by 2. The inner charge on this thing. Second case, when you took A and C, so this charge would be Q by 2, Q by 2, and this charge would be minus Q induced, and this is plus Q induced. They should be neutral. And what is Q induced? Q into Q by 2 into 1 minus 1 by K, which is Q by 2 into 1 minus 1 by 3. That is actually Q by 3. Making sense? All the charge can't be inside here. Why? You can, if you want, you can prove that. In this point, right, this is a conductor. The field inside the conductor should be 0. Therefore, this guy and this guy will anyway give 0. They'll cancel out. That means this guy and this guy also should cancel out, no? You getting the logic? Think about this. For example, if all the charge is here plus Q, this is anyway neutral, so this guy is gone, useless. So due to this Q, there will be a field on the left-hand side, isn't it? So there should be an equal and opposite charge on both the faces so that the field inside the conductor is 0. So this is how the charge distribution would be. Q by 2, Q by 2, minus Q by 3, plus Q by 3. So here the force between A and C would be minus Q by 2 into Q by 3 by 2A epsilon. Same story. Charge into the field due to the other guy. This guy would be minus Q square by 6 into 2A epsilon. That you can clearly see it is 1/6 of FAB. Six is to 1. Maybe you guys took that as, what, Q ले लिया ना अंदर. It should be Q by 2, Q by 2 there. See, the logic still valid. What is the outside charge? Total charge by 2. What is the total charge? The right side is neutral, so Q plus 0 by 2. Outside is Q by 2. Gauss law or whatever you learned will still work. I hope this question is clear. So this is based on Gauss law and dielectric slabs and capacitors. It's a pretty good one. Matlab, this is a little different. Clear? Any doubts on this? Next thing, let's see something easy, which we have already done before. So there, so basically whenever you keep a dielectric slab, the capacitance becomes K times. Let's get this thing. We have seen these kind of questions in heat transfer conductivity. So we have two parallel plates. So this space is filled with K. Area is A by 2. The lower one is filled with 2K. This is also A by 2. Distance between the plates is D. Find C equivalent. In heat transfer, K used to be conductivity, thermal conductivity. This is K. This is 2K. This is 3K. Hope you remember this one. D by 2. D by 2. Area is A by 2. A by 2. Find C equivalent. Hmm. First one was easy. You can treat them as two capacitors, and both of them are in parallel. They have same potential difference. So this would be K. Area became R epsilon by D. This is 2K. Area became R epsilon by D. Both are in parallel, so C equivalent is C1 plus C2. We had done the same thing in heat transfer. So what about B? B is an important question. Hope you remember, right? 2K, 3K are not in parallel. You have to split this into 4 pieces because their interface will have a different potential. We have a very detailed discussion on this in heat transfer. There, this is the version. We have a discussion on this thing. Page 17, heat transfer.
Also, can you show the heat transfer other part again?
Nothing there. See now, basically this part here and this part here, they'll not be identical because the left half and the right half won't be same. The upper section and the lower will not be same. So if their interface is not same, that means the 2K and 3K don't have same potential difference.
Yes, okay, right.
So you can't treat them. So this will be K and K. So split this into 4 pieces. This is 2K, this is 3K. Then you can solve. Clear? So be careful with this. So this thing, I'm sure you can handle this. I'll leave it to you. So this capacitance would be Kc, where C is A epsilon by D. Area becomes half, distance becomes half. So it will be epsilon by D only. This guy is 2Kc and this guy is 3Kc. Okay, series parallel, finish it off. Remember this thing. This is the second time you encountered this thing. First time was in heat transfer. This is the second time. Third time you can see the same thing in current electricity. There they'll give you rho 1, rho 2, rho 3 resistivities. The idea is the same. That 2K, 3K will never be parallel. Clear? Next one. So we have a dielectric slab here. Thickness T. Total distance is D. And this distance is X. Area A, find C equivalent. So you introduced a thin dielectric slab. The whole thing is not filled with the dielectric, only a part of it is filled with dielectric, remaining is vacuum. And this is placed at a distance X from left hand side. So find the C equivalent.
So,
All right.
so in the previous question,
Mm-hmm.
if instead of just K, it was divided into like, suppose 4K and 5K, like instead of K, it was 4K, 5K, 2K, 3K.
Mm-hmm.
So like,
Then you still treat the upper part as one series and this is series now.
okay, ठीक है.
The idea here is whatever is flowing here will continue to flow here. That way. how to do this thing. This can be treated as 3 capacitors. The central capacitor is K, thickness is T, this capacitor ka distance is X, this capacitor ka distance is D minus T minus X. All of them are in series. So 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3. So here C1 would be A epsilon by distance is X. This is K A epsilon, distance is T. This would be D minus T minus X by A epsilon. So when you add them, you will find that X gets cancelled. So D minus T by A epsilon plus T by K A epsilon. So the answer is independent of the position of the slab, meaning you can push that slab anywhere you want and the answer won't change. So C equivalent would be A epsilon D minus T plus T by K, something like this. Independent of X. The slab could be positioned anywhere, the answer won't change. Easy. All three will be in series. Now, let's see a better question than this. So based on this,
So,
hmm,
sir, in the previous wala question, by wo dielectric wala question. So if instead of the 3K, if there was K again, like एक L shape का K था, and there was the 2K, then what, like हम लोग वही करते हैं कि
what is
K,
the problem? Split कर लेना 4 piece में कुछ भी रखो.
okay,
What do you want to do exactly? मतलब, if this becomes K, what will happen according to you? See, is the upper half and the lower half identical?
no,
No, बस हो गया. मतलब interface will not have same potential.
okay, sir.
So there is no discussion that 2K, 3K will never be in parallel. That is the only thing in that question. So for some reason you're obsessed about that K there. But ठीक है, happens. So we have 2 plates here. Potential is there. Let's say this side is grounded. So basically this is 0 potential. This is X is equal to 0. This is X is equal to 5D. Here you kept a dielectric slab K. Somewhere here you kept a conductor. So this is X is equal to D, X is equal to 2D, X is equal to 3D, X is equal to 4D, and X is equal to 5D. Now in the previous question, what would have happened if you had kept a conductor? If you keep a conductor in that region, field is 0, isn't it? You can just remove that space. You're getting it? So if K was infinity, this piece would be just useless. So the distance between them will be D minus T directly. That is the meaning of that. When you place a conductor, that space is gone. You can't store any field there. So that's not a capacitor. So in this graph, plot field versus X graph and potential versus X graph. So as you go from left to right, how will the electric field change with X? How will the potential change with X? Previous question. Just to give an idea for C equivalent, if they suppose I ask you find C equivalent in this question, you can simply treat this as a capacitor plate whose distance is 4d, and you can push the dielectric slab to one side. The conductor can be completely ignored. So the space occupied by the conductor can be ignored or removed. Like I said, the meaning of a capacitor is the region where you store field lines. In a conductor, there are no field lines, so that space is useless. So in this question, if they had asked C equivalent, that is what you would have done. But that's not what I'm asking. Plot E versus X and V versus X. Try it. Take a minute. I'll show you. Slope of a conductor. Let's see. Let's see. So let's see E versus X graph. I think maybe I should show you the diagram first. Let's see. Let's see how will the field vary between them. So here the field E would be E is sigma by epsilon, where sigma is the charge on the plates, whatever it is. Inside the dielectric, the field will drop by E by K. Once you come out, again the field is A. Here the E is 0, it's a conductor. Again the field is E. That is how the field changes. So now if you try to plot E versus X graph, so you have a constant field, then it just discontinues, drops to E by K. Then again it bumps up. Then again it falls to 0. Then again bumps up to E. This is how the graph looks. Now, if you try to see V versus X graph, try to understand the relation. Field is nothing but minus dV by dx. That means in a Vx graph, this is the slope is minus E. So in a Vx graph, the electric field will give you the slope. So initially the potential starts from V. So if you have a high electric field, you'll drop faster. Then your field has become reduced, so the slope will be smaller. Then again it will reduce faster. Then your potential becomes constant, and then again it drops. Let me draw more like
Sir,
this.
can you explain once?
So initially potential will drop because the field is E. इसका एंगल कितना होगा? The tan theta would be E. Agreed? Slope is minus E, na? Then the slope has become E by K. Means what will happen? The line won't be this steep. It would be more flattish. That is in a dielectric. Then again it will continue with the same slope. Then it will become constant, and then again it will continue with the same slope. So if you look at these angles now, these will be theta. This will be theta. This guy, this will be different angle alpha. The tan alpha will be minus E by K. So this is the line which belongs to the dielectric. It will be more flattish because the slope is less. Are you getting it? So you'll have three parallel lines which are coming down, one line and one horizontal line, which is a conductor. So the conductor line, the potential is constant. So this guy would be 0. Is this clear, everyone? So basically, in a Vx graph, the slope is minus electric field. Clear this thing, Udyan? Udyan, got this? Udyan, are you there? Yeah. Do respond. Please focus on the class. Others clear with this thing? Rehan, got this? Kartika, Vidyut? Great. Any doubts on this thing? It's a decent question. It's a good one. Let's see one more. This is R. This is 2R. The dielectric constant K is given by K naught R, where R lies between 2R to R. So it's not constant, even the dielectric constant is changing. And you are connecting the battery between the inner surface and outer surface. So let's say how somehow I connected it. The battery is connected between inside and the outside surface. Right? So, and the outer surface is grounded. So I'm making this basically zero potential. Means the entire outer surface is grounded and this thing. Now, this is actually, this is the space between two conducting shells. Maybe I didn't draw it properly. You understood, I guess. This is the space between wait, maybe I'll just change the color. So these are blue ones are actually conducting shells. In that you filled up a medium. This is better. Whose dielectric constant is K naught R? First question, find C equivalent. We have done exact same questions on heat transfer. And then find potential as function of R. This will be a proper advanced question again. especially the potential part. If the outer shell is zero potential and the inner shell is potential V, what is the potential at a distance r from the center? R lies between R2 to R. Is the question clear? Yeah, how is this question like? Heat transfer. Inside temperature is 2 T naught, outside temperature is T naught. Find R thermal, find the current flow, find the temperature at distance R. We did a lot of stuff. It's a pretty good question even in heat transfer. This is a simpler version of this. Let's get this. In case you forgot heat transfer, just go and have a look at it. It won't take much time. Or else what is there? Next 2 weeks, I'll put an exam on heat transfer and done. You will take care of it. You can always do that. When we used to be in 11th and 12th, our teacher used to ask that only. What is the chapter that you're scared of? I used to give the exam on that. And it used to work. Maybe we used to score bad, but if I had not written the exam, maybe I would have scored 10 out of 100. But after writing the exam, my score would have improved at least to 25. After 2 months, again, one more exam, 35. After 2 months, one more exam, 50. Then you will say chapter is okay. इतना भी खराब नहीं था. So if you don't face your fears, how will you improve? Let's get this. K naught 4 pi epsilon 15 r power 4. I know what you did. You goofed up, I guess. You take the capacitances and what? They're in series, right? Or parallel? You can't integrate integral DC. If capacitors are in series, what do you integrate? 1 by DC is 1 by DC1, 1 by DC2. You should integrate 1 by DC. Integral DC is not a capacitance. Understand the meaning of integral. It is a summation of capacitances. So when capacitors are in series, the formula is 1 by C1 plus 1 by C2. 8 pi K R. Try. I'll give you a minute more. I'll show you. The one thing I can say, capacitors are in series because they have same charge flowing. And when they're in series, the formula is 1 by C1 plus 1 by C2. So it's a summation of integral. That is integral 1 by DC. It's not integral DC. What happened, Ishan? You're so happy. You also goofed up, okay? Integral DC.
I didn't get to that part only.
Okay. That's why you're so happy. Ignorance is bliss, Isa. Something of that sort. कभी कभी होता है medical batches में. I give them a question, I give them 1 minute, then I ask them, did you figure it out? So did you fall into the trap? I was excited. Then I explain them, then they tell me, sir, I'm still writing the question. Here I am jumping like, did you fall into the trap or not? And these people didn't even bother to go in that route. So happens. Let's see. So at a distance x from the center, take a thin shell dx. So for this thin shell, the capacitance DC area would be 4 pi x square epsilon. The thickness is dx into k. So here k is k naught x. So k naught 4 pi epsilon x cubed by dx. How did you integrate this when dx is in the denominator? That is the first thing you should get a doubt.
How did you get x square over there?
Where 4 pi x square surface area. Hai.
Mhm.
A epsilon by d. What is a? Area of the sheet. Surface
Sir,
area.
we won't use the formula of
Which
spherical
one?
capacitance.
Use
4
करो
pi
same आएगा.
epsilon.
यूज करो सेम आएगा. I want to epsilon. तो 4 pi you'll write
I
what?
तो
X
आपने
plus
किया
dx
रहता
whole
है.
square minus 4 pi x square. Ignore dx. It is too small. Binomial approximation. And denominator में क्या आएगा?
So
4
how did
pi
you get
formula
that?
क्या था? 4 pi epsilon x into x plus dx ना.
हाँ,
तो
by
हो गया
dx.
ना. dx को neglect करो ना.
So we can do that. अच्छा ठीक है.
That is the whole point of integration. dx is so small. But you could have treated them parallel plate capacitors, isn't it? The distance is so small. I treated them like parallel plate capacitors. I used a epsilon by d, where a is the area of the surface area of the sheet, epsilon, and dx is the distance between the sheets. Is that making sense, everyone? And now, when they're in parallel, we know 1 by c equivalent is 1 by c1 plus 1 by c2 and so on. So 1 by c equivalent is integral 1 by dc. That is a catch. You can't integrate dc here. So when you do 1 by dc, now you will get dx by x cube into 1 by 4 pi epsilon k naught ka integral. Limits will go from r to 2r. That would be 1 by 4 pi epsilon k naught dx by minus x cube ka integral will be how much? Minus 1 by 2 x square. That would be 1 minus 1 by 4, 3 by 4. So you're getting 3 by 8. Am I right? Yeah, looks right. So that's your C equivalent will be 32 pi epsilon k naught by 3 into r square. Clear with this? The charge on the capacitor would be Q is equal to C equivalent into V. That's the charge on the capacitor. Now what? Basically, what we did here is we treated this thing like onion ka shells. Each shell is a capacitor, and we added all those capacitances in series. We have assumed infinite conducting plates with thickness of dx between each of them. Please have a look at this. In heat transfer, you didn't have this problem, luckily, because all were in series. You could directly do integral dr. Meaning the biggest hint here is that dx will come in the denominator. That itself should told you, boss, something is going wrong. You can't integrate that. Find the potential. That's what makes this question actually an advanced question. This is still fine. How do you find the potential as a function of x or r, whatever? Any doubts on this thing, please ask me. These kind of choosing elements, right? And you have seen this thing at least 2-3 times. We saw one in viscosity also, but there was a cylinder rotating in another cylinder. The same question I can frame again in resistances also. They will say rho is equal to rho naught r. They're also ask the same thing. Find R equivalent and find the voltage as function of R. Ideas would be the same. We will skip that because that is the same as heat transfer. Heat current and regular current, they would behave the same way. Capacitors, this would mess up a bit. How do you find the potential? Think, take a minute. Q by C. What do you mean by that, right? You have to find as function of X, na God. Now see, you said all capacitors are in series. You can say they have same charge. Indirectly what you did actually, you took this battery V here, and then you connected a capacitor, 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 so on, capacitor, and then you connected it back. So this first capacitor started here when X is equal to R, and the last capacitor started when X is equal to 2R. In this, we had a small capacitor DC, whose capacitance DC is given by, we took A epsilon by D, which is 4 pi x square, and epsilon is K naught x into epsilon. This is A epsilon medium by D. By D is dx. So basically, you took the distance between any two plates is dx. Is it making sense now? That is what we did basically. You treated each shell like one capacitor. Now, since all are in series, they have same charge. So I can write the Q is equal to CV, say. So Q is equal to CV. So basically, potential difference is Q by C. Now, V is what? V is the potential difference across the plates. So the small potential difference across the capacitor is Q by DC. Q and DC would be K naught 4 pi epsilon x cube dx. This is the potential difference across that small capacitor at a distance x. Integrate this. So dV, limits will go from 0 to Vx. This would be Q by 4 pi epsilon K naught integral dx by x cube. Now be careful. The potential is 0 at 2R. You took the outer side potential as 0. If you want to write R to 2R, then the potential will be V to Vx. Are you getting this? And this will go to X. This point where potential is 0. This is grounded. V is 0 at X is equal to 2R. Then maybe I'll just put the color. So this is 0. This is Vx. So the potential is 0 at 2R and you're finding at X. There. This is a manageable integration. You'll get it from here. So Vx would be Q by 4 pi epsilon K naught. That is minus 1 by 2x square, and put the limits. So that will be Q by 8 pi epsilon K naught minus, that will be 1 by 4R square. Yeah, something like this. I think it should be reverse. Check kar lena. You got the point. I'll leave the calculations to you. So the main idea is this guy. I can write the small potential difference across the distance dx will be Q by dc. Actually, you'll get a minus sign here since the potential drops. That's why I'm having an issue with the minus sign. As you're going from positive to negative plate, the potential drops. Now it comes fine. I solved using this formula. What is that formula? Q into 1 plus 1 by K8 pi epsilon. I'm not sure where you got that formula from. Here, K is also variable. K is not constant. Is this thing clear, everyone? You used V is equal to E dot dr, great, but what is E? E is the field. And what is the field? Field is Q square. The field due to the inner shell is how much? Q by 4 pi epsilon x square into 1 by k, na? Field is E by k. It is not 1 plus 1 by k. And k ka place mein what you have? K naught into x. This into dr you have to do. You will get the answer. You took the field wrong, I guess. Is this clear, everyone? Should definitely try this on your own again. It's a pretty good question. So if you see in this today's class, right, this one is a pretty good one, 31. 30 ka B is also good, the graph part. This is the standard question B part. This was a good one. This is something new. Putting a dielectric slab instead of a conducting plate. This I have never seen them asking before. So this is also a good one. That infinity thing becomes a capacitor. This thing is a good one. Paragraph again. We did some pretty good ones today. So do check it out. So we're almost done with this. Maybe a little more is left. So next class when we catch up, we will do a few more problems on this. We will do force on a dielectric slab. Maybe we'll do 1 or 2 more problems like this, and then we'll wrap up. And next class we'll start off with current electricity. So yeah, mostly I think another 40-45 minutes, and then we'll start off with current. Current would be even more variations. That will be even better. But as far as circuits are concerned, whatever techniques you learned in capacitors, it's the same techniques in current also. So that would save time there. So there's no need for me to teach you again that symmetries and